Okay, welcome back to Physical Science Online, Horsepower Lab number 2. So at the end of the first video, we got to the energy that it would take me to get up the hill. We're going to use that energy conversions, not real life, but perfect world. We're always ignoring friction. We're ignoring stuff like the angles are different and some energy is lost and what yada, yada, yada. It's not perfect, but it's close enough. If you take physics later on, you'll have some of those conversations about why real world actual calculations are super hard because of all that stuff I was kind of just mentioning. However, for this lab, we're going to pretend like none of that exists, and we're just going to use your data, your time up the hill, your time to get to the top of the stairs, and do some calculations. So the work of the climb is going to be basically your force times the distance. And the work of the climb is not the most important part of this lab, but it does get us at a concept for our big lab for the year, which is egg drop lab. And that's why we're doing the work equation. So let's see here. Work is just the energy you need to get up the hill. So my work is going to be equal to 3,726.5 joules. Take your work. You can find out how much force you applied over that distance. You could actually measure, if you were on a hill, you could measure the length of the hill, or you can measure the actual angle of the stairs. We won't need too much. We're going to consider like you were going straight up. Once again, perfect world. So we're going to say that our distance is our 3.9 meters. Solving for force, you just divide the two, and you can kind of get a general sense of how much force your legs were exerting as you went up those stairs or up those hills. So if we take 3726.5 divide by 3.9, and we get about 955 newtons of force. So that's just your force that your legs were exuding the whole time. And it also gives you a really good idea of how you could increase your work, the amount of energy that you did. You could either increase the distance or you could increase the force. If you increase the force, you'd be doing more work, and then you could change your numbers a little bit. Or if you decreased your distance and kept the same force, then that would have less energy overall as well. So something to think about as we move forward here. Real one is power. Power equals work divided by time. So we're trying to calculate our power in watts. So I'm taking my energy to get up the hill, dividing it by the time it took me to get up the hill. Me, it took 4.2 seconds, 4.26 seconds. Whatever it takes you is what you would plug in. And you would figure out that your power is 3726.5 divided by 4.26 gets me 874.8 watts of energy. Last thing to do here, give you the conversion ratio at the bottom here, that horsepower is equal to 746 watts. So you divide this, whatever number you got here for your power, divide it by 746, and you will get your horsepower. So the power of a horse. Remember, just a random horse out in the middle of the field of whatever it is. Mine is 1.17 horses. Then I could go back if I'm not satisfied with that and try to get a better time, or change the distances of my hills and stuff like that. I think you can do the calculation or the end of lab questions based on that calculation explanation, getting you to think about what it means to have power and to change the amount of energy you need at different points in time. That's all we got.